Okay, so we're going to have a look at chapter 2, which is called Measures of Location and Spread. And the things that we do in this chapter are going to be pretty familiar. We're just going to kind of extend them into a bit more of an A-level style. So we're going to think about mean, median, and mode, really simple stuff, quartiles, percentiles, and deciles, which is mostly going to be new. Variance and standard deviation, which will be new if you haven't done statistics at GCSE. And then last of all, coding. And we're going to get really, really good at using our calculators for this because it can do an awful lot of the work for you. So I wanted to do a few things in the introduction to talk to you about because this is sometimes an area that people get confused on. So I wanted to talk to you about variables in algebra and variables in statistics. So if I had this letter X that I've got here, it would mean quite different things in algebra and in statistics, but there are some things that is similar. So just like in algebra, a variable like this letter X in statistics represents the value of some quantity. It might mean shoe size or height or color or weight. This just represents something that is some quantity. As we saw in the previous chapter, variables can be discrete or continuous. And these things that we write here, they can be part of further calculations. So for example, if x represents the height, then 2x represents twice the people's height. And in stats, this is known as coding, which we'll be covering later. So we do some manipulation with these variables. But there's quite a lot of differences between variables in algebra and statistics. So unlike in algebra, a variable in statistics represents the value of multiple objects. So it's a bit like a set that we talked about in things like Venn diagrams. So for example, it could be the heights of all the people in the room could be written by this letter X. Now that doesn't mean that they all have the same height, but we just use this letter X to refer to the height of all the people in the room. So because of this, we can do operations on it as if it was a collection of values. So if X represents people's height, this thing here, sigma X, or the sum of X, gives the sum of everyone's heights. In algebra, this would be meaningless. If X is equal to 4, then the sum of X makes no sense. It's like saying, well, what are you adding up? Let me just quickly write this down. This means the sum of the X values. So in algebra, that wouldn't make sense because usually we would just say that X is one value. But in statistics, it will make sense. It will mean add up all of the people's heights. We then also have this thing here. You can have the letter X and there's a line drawn above it, which we call X bar. So I'll just write down what that means. We call this X bar when we say it out loud because of that bar on the top of it. And X bar is the mean of X. Notice that X is a collection of values, whereas X bar is actually now a single value. So that's kind of just a subtle difference that although X can refer to many things, we can then suddenly change it so it represents just one value. To each value of the variable, we could attach an associated probability. This is known as a random variable. So if we had some probabilities about people in the rooms and stuff, we could attach those to these different values and we would say that it becomes a random variable if there was some kind of probability thing happening with it. So just be careful. When you see an X in statistics, it doesn't necessarily mean it will behave like it does in algebra. And now I wanted to talk to you again a bit about some of the introduction of this to talk about how we measure things in data handling. So there are two things we're going to be talking about. We're going to start off thinking about measures of location. And then within that group, there are these things called the measures of central tendency. Let's just think about what that actually means. Measures of central tendency that I've written down here are to do with the center of the data. So like the idea of an average. The median, the mean, the mode, these are all numbers which we try and use to summarize all of the data in one single number. That's really what these averages are trying to do. We're trying to pick one number that will represent a whole set of numbers. But then what I've written here is that measures of location are single values which describe a position in a data set. So these are a specific type of location. They are the center. We're trying to say what does all of the data kind of center around. But you could also measure other things like a maximum or a minimum or a quartile, which you probably know. Percentiles and deciles, maybe not. This is still a measure of location. If you tell me about the maximum height, we're talking about how tall that tallest person is in the group, or the minimum, how short the shortest person is in the group. So these are all measures of location. We then have a completely separate set of measures, which are called measures of spread. And measures of spread are to do with how data is spread out. So you already know that the range, and unfortunately, range often gets caught up with the mean, median, and median, and mode from GCSE. But the range isn't measuring anything to do with the location of the data. It's telling you how spread out it is. And we're going to learn about some other ones from here as well. So that's just a bit of an introduction. What we're going to be doing in the next video is exploring how we can use our calculators to perform lots of these rather boring operations all automatically.